Hi, as Jason mentioned, I'm Morgan McLean. I'm a product manager at Google based in Seattle, Washington. I'm the PM for a number of our products under the Stackdriver brand, particularly Trace, Debugger, and Profiler, which are some really cool production tools that we offer to our customers and indeed any developers around the world. I'm also the PM for this new project called OpenCensus, which I'm talking about today. So I'm going to walk through and give you a bit of background on OpenCensus. For some of you who are already familiar with the project, this will be basically just rehashing things you've already heard. And then we're going to delve a bit into the roadmap. So from a very high level, our goal with OpenCensus is to make instrumentation really, really easy for developers. So being able to get data out and telemetry out of their applications and being able to send them to some backend for processing. Our long-term goal, while this sounds somewhat ambitious, is for instrumenting their app with OpenCensus to be one of the very first things that they do when starting a new project or when trying to add instrumentation to an existing project. It sounds ambitious, but it's sort of a goal we set for ourselves. So to walk you through the story, we're going to start with like a sort of a basic monolithic app. This probably makes more sense in the concept of web services, but in theory, you could also apply the same kind of thinking to a phone or desktop application. And I think we're all pretty familiar with the different ways that we can sort of get observability from our application, right? In a simple case, you can use stack traces, metrics, and logs. You can do performance profiling and do code debugging in order to find out how your app runs, how you can speed it up, how you can improve performance, and finally, how to do root cause analysis. This isn't sort of rocket science to anyone here. These have been concepts for the last 10 to 15 to 20 years. And in some sense, this gives us what we call observability. I know this isn't quite what most people think, given that we're at a conference that focuses on distributed systems, but this is how you would actually get some insight into how your app runs and how to fix it. So the next thing we do is we move to a slightly bigger set of services, right? So whether you want to call this microservices or not, we've broken our monolith into a couple separate components. Those are running on maybe separate VMs or separate containers somewhere, and they're talking to each other. And getting observability from this is a little more challenging, though it's technically not impossible. If you've got 3 different components to your application, 3 separate hosts, it's kind of annoying, but not the end of the world to go and get the stack traces and logs and other metrics from each one of those. But then we move into this crazy, crazy world that we're in today, where you have companies with hundreds or thousands of services running all over the place, and suddenly the concept of getting a stack trace or getting logs out of all these hosts becomes quite challenging. This probably isn't a surprise to anyone, given that we're at a monitoring conference, but this is the journey that developers have been on for the last 10 or 5 to 10 years. And so our existing concepts of observability that we were relying on before start to break down, right? Like a stack trace on a system where you have a request that goes through 10 to 100 different nodes and your stack trace only shows stuff from that one node is pretty pointless. It's useful if you have an issue where you already know it's localized to a single host or localized to a single part of the app. But in your larger context of your distributed system, it all starts to break down. So it's probably important to up-level this. When developers think of observability, they're not thinking of the things that we sort of talk about at these conferences. They're not specifically thinking like, gee, I need distributed traces specifically, or I need this thing specifically. What they really want is context into how their application works. So there's a number of different ways of describing this. Probably one of the most common that I hear is like understanding the topology of their application, understanding how their services and parts of their app are laid out. The next is understanding the status of their application, right? Think of this, if you want to think of this in like concrete terms, this is metrics over time, logs over time, events that come out of the app over time, but really just understanding its state through time. And finally, they want to be able to perform root cause analysis. Certainly the first 2 pillars of this factor into that, but additionally, there are extra tools you can build or extra things we can do with that data that allow people to have very specific root cause analysis focused workflows. And so OpenCensus is really a project that we're pushing pretty hard in order to make observability much more accessible to everybody. Today, there are challenges, whether that's simply like the price of some solutions in this space, or just the ability to set things up and extract the right telemetry from your app in order to better understand how it works. And so we want to make this easy. To jump back into like those more concrete concepts, we're focused on extracting distributed traces, tags, which are a way that we enable correlations, and metrics from applications. I've also highlighted logs here. Right now, we're not focused on like extracting logs from apps, but it's important to get the sort of correlations between traces and metrics and logs in there. Getting this out today is not always the easiest thing, as I mentioned before. Tracing in particular is very, very difficult to instrument. And so with OpenCensus, we're trying to make that easier. And just to give you a bit of an explanation, because it looked like I went very high level and very low level, we're focused on these because these are concepts that most vendors in the industry focus on today. So we're not going to be pulling out things like continuous profiles or production, giving production debugging support, not yet, because there's very, very few vendors that support that. We're focused more on just getting out the data that people already understand or already used to. And just to give a bit of background on the name OpenCensus, so within Google, within our internal platform, we already have a project called Census. It's been there for 5 to 10 years. This is how we at Google extract traces and app-level metrics from our apps. For us, it's completely automatic, which means that anytime you write code at Google, it effectively just gets traced magically, which is really, really nice. Obviously, that's not always true outside of the company, which is part of the reason that we're open sourcing this work and extending it so that external developers can take advantage of it. So to dive into this a little more, with OpenCensus, we're providing a single distribution of libraries across various languages that have support for, like I said before, distributed traces, metrics, and tags. So this isn't just like an API or interface. These are actual libraries for C++, Java, Go, Ruby, Python, PHP, Node.js, and .NET. Our C++, Go, and Java libraries are already like totally functional complete. Ruby, Python, and PHP have tracing support, and we're adding metric support right now, and that'll be finished in a few weeks. Node.js and .NET will be starting work on soon. Within each library, we provide actual integrations and instrumentation, right? So today, we already provide support for gRPC, HTTP, and various storage clients. There's a, like MongoDB driver, for example, has support, as well as a number of others. So we've already got the core set of integrations right out of the box that developers can take advantage of. And we also have integrations into various platforms. So Oracle, for example, recently released some kind of serverless platform called the Function Project. It already comes with OpenCensus built in. You're going to see the same with a number of other projects, whether that's Istio or other things coming out of Google or other vendors. The next level in the OpenCensus libraries is the actual API. So in addition to capturing traces and generally RPC stats automatically, so as soon as you link the library to your app, you're going to start capturing those. We also offer APIs that you can manage things like trace sampling, so you can add spans to a trace, add annotations to those spans, change any of the tracing behavior. You can also use it to define custom metrics, right? And so think of like the Prometheus client libraries as sort of similar functionality to those when it comes to the metric side. But we provide the full API support for any manual intervention or manual instrumentation that developers want to use. And finally, we have this concept called exporters. Exporters are what allow you to get the data and telemetry out of OpenCensus into your backend for processing. For example, for tracing, we have exporters for Stackdriver, for Zipkin, and for Jaeger, and for metrics, we have exporters for Stackdriver, SignalFX, Prometheus, and a couple of other backends. And there are actually some vendors here who are in the middle of building additional exporter support for OpenCensus, so we're pretty excited about that. One other thing, just as an aside, we also are supporting the new W3C trace context propagation format. That was an effort that we kicked off in addition with the Zipkin project. It's now progressed to include a number of other vendors, and it's moved under the W3C. So we're really, really excited about that. OpenCensus supports that. To be clear, it's being run as a separate project, though. So now I want to talk about how you actually get OpenCensus into your app and how it sends data to the back end. I'm doing this just to provide a high-level explanation, but I'm also doing this because in a few minutes, I'm going to talk about some of the things that we're doing longer term that are going to change this. So at a very basic level, you simply link the OpenCensus libraries to your application. They'll attempt to automatically instrument as many things as they can. So generally, that's HTTP, RPC, storage clients, and web frameworks. And they'll capture that data and be ready to send it to a backend. Additionally, as I mentioned before, you can always use the API to manually interact with these and create your own telemetry. In a sort of standard, what we're viewing as our sort of standard open source deployment case, you're going to have typically a tracing backend and a metrics backend. And you can support multiple exporters at once. There's no real hard cap on it. And so what we think is a really common deployment scenario is people will have Zipkin and Prometheus. And so you can do this, and you configure each OpenCensus library to talk to Zipkin and Prometheus and send the traces and stats to the right backend. And everything will work great. And so this is sort of the most common way we expect OpenCensus to be deployed. It's pretty straightforward. As you can see, there's some things missing here. For example, the client application is not instrumented yet. I'm going to talk about that in a few minutes. So just before we get into like the things that we're going to be doing with OpenCensus long term, I just want to cover some of the benefits of it. The first is we've designed it to be really, really easy to set up. Like some of these tools, depending on which vendor you're using, like or what language you're using, because some languages are certainly much harder to instrument than others. Today it can be very, very difficult to get data from. You won't always get traces from like storage clients, for example. And sometimes you'll need to do things like propagate context on your own. We have tried our best, and we continue to make huge investments in this. OpenCensus has a pretty big team at Google to make this as easy as possible for developers so that the kind of tools that a lot of us are used to, and indeed a lot of the people here are working on so we can sell them and build a great market out of this, are really accessible to developers. OpenCensus has great language support, so officially we cover 8 languages. There's also an additional community-built distribution that supports Erlang, so that's a total of 9 languages. That's quite a bit of breadth, considering that other solutions for instrumentation generally just focus on a few. And it also helps that we have a single distribution per language. So one of the problems that we've observed in other communities, I think initially it was like Zipkin, for example, when we were starting OpenCensus, was that you might have like multiple competing distributions. So I think the example we had was that like Zipkin for .NET or Node had like 3 different libraries that effectively tried to instrument the same stuff. With OpenCensus, you have a centrally managed project with 1 distribution per library. So all of those integrations, all of those exporters are being managed in a central way, and so you have all the effort being applied to the sort of single core project. The next is the integration. So as I mentioned, we try and get as much data as we can out of the box. This typically has been one of the most sort of expensive parts for vendors. So particularly in tracing, I'm sure many of you, anyone here who works on instrumentation, can attest to like the sort of annoying difficulty of getting traces and spans automatically out of application code. The whole idea here is that multiple vendors, so Google and whoever else wants to join, and there's already a ton of them participating, will be able to collaborate on this. So rather than everybody having to go instrument some framework for Node.js separately and doing all their own work to do that and spending months and maybe even years of development time, we can do it in one spot. And indeed, once this becomes successful, and we've already seen this in a few places, we can get these hooks built into some of the frameworks that we're trying to get data from. So like gRPC now has native hooks for OpenCensus, and so we don't even really need to maintain that integration. The same is true for the function project that Oracle's working on. It provides a ton of benefits to customers because they're flexible in the backends they can use. Right, like they can either very easily try and evaluate other vendors' backends. They can switch from maybe an open source backend to a paid vendor one very, very easily. So it's a much easier conversation with those customers about, hey, why don't you give our stuff a try? You don't have to go, deploy a bunch of our agents and change a bunch of your code. You change a single line of config, redeploy your app, everything works, and you can still continue to export to the backend that you're using before. And finally, we provide correlations. I'm going to talk about this in a second, but one of the challenges we've seen today in frankly, a lot of our own solutions and others is that it's difficult to correlate different signals together. So for example, traces and logs aren't always correlated, and that's a really powerful thing. It's something that we enabled for Stackdriver 1 or 2 years ago, and we thought it was pretty minor, but our customers got a ton of value out of it, being able to see all of the all these various signals in the context of a customer request. And so one of our big key focuses is making this automatic. And so like here's an example of something we do with Stackdriver, but in theory any vendor can do it with OpenCensus because the correlations are there. Where when you capture, wow, that's blurry. When you capture a log in the context of a trace, we can show that inside the trace span view. And then in the log, we've embedded the trace ID. And so in this case, like even if you're using 2 totally different vendors for like tracing and logging, like you're using, I don't know, Zipkin for tracing and Splunk for logs, by just embedding that data there, you always know as a developer, you can always go search your logs for that trace ID. And if the logs have a trace ID, you can always jump back to trace. And that's really, really powerful. That's not something that's always possible today without a lot of manual work. And I mentioned root cause analysis earlier. So one of the other things that we're doing with OpenCensus that's sort of outside of the telemetry path is this optional, what we're calling a Z-Pages agent. So these exist at Google. This is sort of another part of the census project from within Google that we've wanted to open source. And these are an optional agent that you can put on every single one of your hosts or just hosts you're interested in that talks locally to your census instrumentation. It effectively just gives you the fire hose. So traces are almost always sampled, for example. But what we'll have here is a small local buffer where the Z agent is able to pull in the data from the tracing instrumentation. And it can't show you traces, but it can show you all of the RPCs that have gone through the system in the last few minutes. And it's really useful if you think you're having problems with a particular host or a particular part of your app. You can just jump here, get the complete fire hose view of data, and then jump to your higher level metrics or tracing solution to go in depth across your system. We're curious how other people use it. It's certainly a path that we use a lot at Google. We're interested to see if this is also of interest to people in the community or not. So that's kind of like the high-level overview of the OpenCensus project. What I wanted to do now, rather than a demo, because we've done demos at previous presentations, and to be blunt, for a room full of people who work on monitoring and tracing, a demo of the instrumentation probably isn't that exciting. I want to walk through some of the features that we're going to be building into OpenCensus for the next few months. So we plan for most of these to ship within 2018, and some of them I think will be pretty exciting to everyone in the room. The first is just more finishing our language support. So as I mentioned before, we have full support for C++, Java, and Go. In the next few weeks, we're going to have tracing and metrics support for Ruby, Python, and PHP. And then that's going to be followed with tracing and metrics support, which we're just starting from scratch on for Node.js and .NET. Oops. The next is building out our list of integrations. So we already have most HTTP clients. We already have gRPC and a bunch of web frameworks and storage clients. We're just trying to build this out, right, and get as many different sources of instrumentation as possible. And we're also building support for Istio. So if anybody here is really interested in that, we'd love to talk about it. I did a talk at KubeCon specifically about our Istio integration. So if that's something that interests you, it's probably worth investigating. The next, though, is what we're calling intelligent sampling, followed by client app support. And I'm going to dive into these because they're actually pretty exciting. So this is a sort of sample census deployment, right? So like today, we support a SignalF exporter for metrics. And so this is a way that a customer might have their app instrumented where they're doing traces of Zipkin, metrics of SignalFX. Now, one of the things, there's a couple challenges here. So the first is you have every node talking to the internet. Now this is actually pretty normal for any of the sort of SaaS-based vendors here. It's how Stackdriver works as well. But for various reasons, it might not be desirable. Like first off, if you have a lot of nodes, each of them's opening a separate connection with your vendor. And secondly, just from a security point of view, like there are cases where it's desirable to have nodes that can't access the internet. But if you want to send that data back to your vendor who's not hosted within your application, that's not possible. Second is that the client application here isn't instrumented at all. And if we think of tracing, like distributed tracing is really, really powerful, but most of us only do it within our own backend applications. We don't always capture the full like customer-centric end-to-end trace, which is unfortunate, and so we'd like to fix that. And so one of the things that we're thinking of building, and we've already started the design process on, is building a sort of aggregation or buffering container that can capture the data from OpenCensus clients and actually possibly different other clients as well. And it'll buffer it, perform some basic aggregations, and then it'll forward that data to your backends of choice. This has a couple advantages. So first off, it makes the configuration of which backends you want to use centralized, which has some benefits. It means if you want to send data to a different source, you don't have to redeploy your entire application. In cases where OpenCensus is built into your platform, so we talked about like Oracle's function project earlier, and there's some other sort of open source platforms that will be coming out soon with OpenCensus embedded into them. It means you don't have to like go rebuild all that platform code, because without this container that forwards data, you'd have to like effectively like go rebuild your platform, which might be really annoying. You can also let's see here. So we also have some opportunities for better sampling. So one of the challenges today with sampling distributed traces is that it's typically random, right? So this is an example of the Stackdriver UI, and like one of the really, really annoying things here is that on our scatter plot, like by far most of the traces that we collected are for health checks. And even if we excluded that health check, typically most of the traces that you collect, when you're doing random sampling, will be for requests that frankly aren't that interesting. As developers or ops people, we want to trace requests that are slow or correlated with an error or correlated with some other kind of event that we think is interesting. And when you randomly sample, like 99.9% of the requests you get aren't going to be interesting. So one of the things that we're working on for OpenCensus is what we're calling more intelligent sampling. You could also call it deferred sampling or retroactive tracing. And so the idea here is that we can capture traces selectively. So in this case, for example, we might want to capture a trace based on accumulated latency, so that our trace collection is skewed towards requests that are slow, rather than just randomly sampling requests. Another example is we would probably want to capture traces every time your application has an error or some kind of unhandled exception. So you can always get a trace from that. The tracing collector that I showed earlier is a great way to do that. It makes it a little easier. It means you can get the full, full trace in the case where you've made that sampling decision several layers down the stack rather than on your edge. There are some techniques you can use, and we're investigating those as well, where you don't need that additional part of your application running there, rather that additional container running there, and you can capture traces, but just get the critical path prior to the sampling decision. But having that container there makes it a lot easier. Let's see. And finally, one of the other things we can do with this container is get telemetry from actual client applications. So as you can see in this example, the client application is actually instrumented with OpenCensus, and we're working this year on libraries for Android, iOS, and front-end web apps. So you can get traces and metrics and other telemetry from those client apps really easily. Now, normally you wouldn't, like, speaking as a vendor, we don't necessarily want, like iOS apps and Android apps talking directly to Stackdriver. I'm sure the same is true for any vendors here, right? It means you're sharing some kind of secret to the customers of your customers, which probably isn't the greatest security practice. It also means you just have this whole bunch of nodes sending data to your backend. It's kind of annoying. And so with this container, the way we think it'll work is that developers will capture all that telemetry with the OpenCensus library based in within their customers' applications. They'll pass it back to their own backend via the APIs and authentication authorization that they already use. They'll then pass that data to the OpenCensus container, which then takes care of it, sends it to their backend of choice. And so it's an easy way for customers to get this, and indeed vendors here to get actual client application telemetry to their backend. So it's really nice. Another thing that we're going to build with this is what we call cluster-wide Z pages. So I showed you those Z pages a few minutes ago, where you can get the sort of the fire hose of tracing the metrics information. Typically those are only run on a single host. With this container or this sort of application you're running inside of your app, we can aggregate that off of a couple of hosts and give you just a better experience for it. So I'm about to wrap up, and then I'll open the floor for questions. So if this is a little abstract, I apologize, but with OpenCensus, we're offering a single distribution of libraries that capture traces, metrics, and tags, and perhaps eventually other types of information, whether that's logs or profiles from customers' applications. We're going to give people out-of-the-box observability and the ability to send this data to whatever backend they choose. All it requires is an exporter. Exporters are very easy to write. It's a very small amount of code. And with one, you can get OpenCensus sending the data to your backend, sending traces, metrics, and whatever else we end up supporting. So there's a lot of benefits for developers, right? We're bringing observability. We're bringing, in some sense, these APM concepts directly to developers and making it really accessible for them to get started with all the products that people work on here. And it's really powerful for vendors, right? Like, in theory, this will massively expand your customer base and also potentially reduce one of your biggest sort of pain points and cost centers, where developing that instrumentation is incredibly difficult. OpenCensus is very focused on application-level telemetry, so we don't capture system-level stats or anything like that. You'll typically still need an agent for that. But getting stuff out of the app is generally the most difficult thing that a lot of us wrangle with. Getting system-level telemetry is a relatively solved problem. All right, and so I actually have a couple minutes left, and I'd love to take any questions from the audience. I see someone over there.
So you talked about backtrack sampling.
Yeah.
How is that done exactly? Do you record a buffer with all the traces and then some event to the app?
Yeah, so there's a couple designs that we're going through right now. One of them is where we keep the buffers on each host. Another is where you're using that container and the data gets sent to the container and it's all buffered there, and then we go through it there. We just have to pick one and start building it. But we're sort of pretty far through the design process. We're just building a couple prototypes right now and playing around with them. To be clear, all of the retroactive sampling and everything I talked about here, that's part of the open source project. It's not going to be vendor specific. There's no vendor specific code in OpenCensus.
I have another question.
Sure, yeah.
Can you talk a little bit more about the Istio integration?
I can, yeah. So we're building OpenCensus tracing support. And and metrics support into Envoy, and then later into the Istio mixer. So you can automatically get spans out of Envoy. One of the challenges of Istio, though, is we still can't automatically perform those correlations. So if you want full tracing with Istio, you're still going to need to link OpenCensus to your application, but at least we can get that additional metadata out of the Envoy proxy. We have some work planned with the Istio mixer, likely just bringing a lot of the functionality that I talked about for the container here into the Istio mixer. And so, if you have the Istio mixer running with your application, you'll get a lot of that sort of aggregation and retroactive tracing functionality for free out of the box. Other questions? I see a hand over there.
Adding the OC library to the client application. When you add the OpenCensus
Yep.
library to the client application, how are you ensuring it's authenticated back to the OC container? Like, I know you said one of the reasons we don't do it today is because we want to pass client secrets out to those when they add phone app or whatever.
Yep.
How are you doing that with the OC container?
Yeah, so again, it's not going to talk directly to the container. There is a bit of manual work here for anyone who's implementing this, and that's unfortunate but probably required, where they're going to be using whatever authentication systems that they used for their app to talk to their back end. They're going to have to rely on that. So we're not going to provide an out-of-the-box auth mechanism there, because as you pointed out, I don't think there's a magic bullet that can take care of it. I wish there was, and if there is, we will go implement it. But yeah, that's one thing devs are going to have to take care of on their own. I see another hand next to you. Yeah.
Can you talk a little bit about the intelligent sampling and correlation with logs and those that
Yeah. Yeah, I'll start with the logs part, actually. So we're doing work right now, and I think some of it's actually already being published, where we're integrating with various logging frameworks on languages to try and insert a trace ID into the logs when we can, right? So that's like integrations with like Log4j, for example. Longer term, we've actually been debating, and we don't have a clear opinion within the team or with our partners, and it's something we're still talking about. And if you have opinions about this, please come find me after my talk. About like making logging a first-class API within OpenCensus, so you could actually like write your logs with OpenCensus. Exporters would then send those to the backend of choice. This would make doing correlations really, really simple, right? We're bringing more telemetry into the library. We can automatically do that correlation. It would also mean we're effectively like reinventing the logging wheel once again on languages like Java in particular, which is why we're not necessarily keen on doing this. So yeah, right now we're doing the integrations and just basically building integrations for all the various different logging frameworks, and then longer term we might do first-class logging. If people have strong opinions about that, please come talk to me. I'd love a brain dump from people who know a lot about this. Did that answer your question? Yeah, so that's what we were talking about a minute ago. So that's capturing traces based on accumulated latency, basically moving that sampling decision down the stack, or on other events. Other events might be, for example, errors in the app. So every time you have an error, it'd be great to always have that trace. You effectively have like this big distributed stack trace for every single error. There are other opportunities to take advantage of it. For example, like we have a production debugging product at Google. We'd love to always capture a trace when we hit a snapshot. I'm sure there are other things that people can think of here where there are events that you always want traced within your distributed system, which is really, really difficult today, if not impossible. Yeah.
Yeah, that's kind of a lead into my question, which was, have you thought about using libraries to link it to the client apps so that when the client experience becomes degraded, you actually initiate a trace?
Bingo. Yeah, and so that, oddly enough, that would like be actually a little easier today, but yes, that's exactly one thing we've thought about. So like any place where you've got latency or some kind of bad experience, being able to like always capture a trace. Because today, when you sample it, like, I think most people do like roughly 1% sampling, like you have a 1% chance of capturing that, which is actually pretty low. It's a bad experience. Yeah.
I don't know how many more questions you have, but would you mind repeating the question so that everyone can hear it?
That's a really good idea. I apologize, I didn't do that, but I will do that for the future ones. Thank you. Assuming we have future questions. Anyone else? Oh, perfect, thank you. Sorry, it's kind of blinding with the projector.
Actually, you don't do system telemetry, but have you guys measured the overhead of like the tracing that you guys do at Google?
Yeah, and so the question was, we're not doing system telemetry, but if we measured the overhead of the tracing we do at Google. So at Google, we sample at a ridiculously low rate. As I'm sure you can appreciate, the volume of requests that come into Google is relatively high. And so we sample it below 1%. And a lot of that is to not impact performance. Though, to be fair, like capturing tracing telemetry doesn't massively impact the performance of an app. It's mostly just to reduce our backend storage costs. Because storing and capturing those traces can be quite expensive. usually with like 1% sampling or even with the retroactive tracing that we're doing, we don't expect to have a very high performance cost at all. And all of the things that we work on with OpenCensus are designed to be running in production 24/7. And so anything that had an appreciable performance cost would be a non-starter for most potential customers. More questions? See, way back there, yeah. We're always hiring. So I'll take that in 2 ways. So the OpenCensus project, we are like super, super open to have more collaborators on it. We've got some fairly large vendors who are probably like days or weeks away from having a big announcement about. But if you're an individual or another company that wants to work with us on OpenCensus, we are definitely hiring. The team is also hiring, as is Google. But yeah, if you're interested in working on OpenCensus, working at Google, or just collaborating for the project, we would love all of those. Right now, OpenCensus is a Google, like entirely Google-run project. That will change in the coming days or weeks. We do not want this to be like just another like sort of Google open source project that we manage. We want this to be a community thing. And we're in a place with OpenCensus where like I think all of the vendors here and people in the space have really, really aligned interests. They all want to make this easy. And so we're really excited to bring more people on board. Right there, yeah.
If you are not using one of those support languages,
Yeah.
what is the roadmap of implementing it,
Yeah.
from the open source side, like what do we have to do?
Yeah, so the question was, if you're not using one of those one of the languages that we called out, so the 8 core ones, what's the process for getting started? Just reach out to us. We can like give you a repo within the OpenCensus organization, and you can start on that. We already have the Erlang group doing that today. They've made a lot of progress. We'd love to see more languages show up. How am I doing on time? 0? Okay, I guess that's it then. So thank you very much.